Good morning, students. Once again, welcome to the revision class lecture 8 of Design of Machine Members 1 for second year, second semester mechanical students. Today in this lecture 8, we'll have the introduction of quarter joints, what are the various types of quarter joints, and what are the design configurations and associated problems. We will discuss the quarter joints, the types of quarter joints, the design conditions, and the failures and the problems. Right? Yes, we'll switch on to the class. 12. Next, coming to the quarter joints types and design. So as already discussed in the last class, the notations of this one and the various notations of different types of joints. Next, coming to the types of quarter joints, we have three types of quarter joints that we are to be discussed in this syllabus. That is the socket and spigot quarter joint, the sleeve and quarter joint, the gib and quarter joint. So this is the figure of the socket and spigot quarter joint where I've mentioned in the earlier class also, right? So when you get a question, design or sketch and explain a socket and spigot quarter joint అన్నప్పుడు మీరు ఫిగర్ వేసి నీట్గా వేయాలి. స్కేల్ యూస్ చేస్తే మీకు చాలా టైం పడుతుంది యాజ్ ఇన్ కేస్ ఆఫ్ మిషన్ డ్రాయింగ్. రఫ్గా వేయండి బట్ నీట్గా వేయండి అండ్ షో ద నొటేషన్స్. Next, coming to the design of this quarter joint, design of socket and quarter joint, the dimensions of socket and spigot quarter joint may be obtained by considering the various models of failure. Though we can design the socket and spigot quarter joint. So in the first one is the failure of rods in tension. The rods may fail in the tension due to the tensile load. We know that the area is pi by square, pi d square by 4. Then the tearing strength of the rods is equal to pi d square by 4 into tau t. Then equating these two, we will get P is equal to pi d square by 4 into tau t. So from this equation, we can find the diameter of the rod. For example, if you get any question, design the socket and spigot quarter joint ఇచ్చి అని చెప్పి మీకు కొన్ని values ఇచ్చి ఒక క్వశ్చన్ ఇచ్చారనుకోండి, you have to start doing all these types of failures, right? So ఏం చెప్పాలి, given data రాసిన తర్వాత design the rod in tension, design the spigot in tension across the weakest section అన్ని రాసుకుంటూ you have to solve the problem. Or if you get your design data book in the main exam, it is very easy to solve the problems, right? ఎందుకంటే డైరెక్ట్ ఫార్ములాస్ దానిలో ఉంటాయి, దానిలో చూసుకొని దీనిలో మీరు సాల్వ్ చేసేసుకోవచ్చు. నెక్స్ట్ సెకండ్ వన్ ఈస్ ఫెయిల్యూర్ at the weakest section. Therefore, area resisting tearing of spigot across the slot is equals to pi by 4 d square d2 square minus d2 into t. And tearing strength of the spigot across the both slot is equals to pi by 4 d2 square minus d2 into t whole to the power of sigma t. Next, equating this two, we'll get the formula is P is equals to pi by 4 d2 square minus d2 into t whole to the power of sigma t. If you see the thickness of the quarter, this is the d2 diameter, this one is a t. Now what is the third one? The third one is failure of rod in crushing. We know that the area of resisting crushing of rod is equal to d2 into t. The crushing strength is equals to d2 into t into sigma c. Therefore, equating these two, we will get load P is equals to d2 into t into sigma c. From this equation, we can determine what? We will determine the crushing stress may be obtained. Next, fourth one. Sorry. Okay, no problem. So the next one is failure of quarter in the shear. So diameter kanukovali, tarvata crushing stress kanukovali, tarvata shearing. So since the quarter is a double shear, therefore the shearing area of the quarter, student, the quarter is a double shear. If you have some portion of the quarter that is sheared, you can see the breadth and the thickness. With this, the area of the quarter is 2 into bt, and the shearing strength of the quarter is equal to 2 into bt into tau. Therefore, the equating this load P is equals to 2 into B into T into tau. 2 into B into T into tau. So with this, we can determine the tau value. Now, what is the next one? The failure of the socket collar in crushing. So, ఇక్కడ socket ఇక్కడ వచ్చేసి socket and rod crushing, ఇక్కడ socket collar crushing. So, we know that the area of crushing of the socket collar is equals to d4 minus d2 into t, and the crushing strength is equals to d4 minus d2 whole of t into sigma c. Therefore, the equating these two, we have p is equals to d4 minus d2 into t into sigma c. From this equation, we can determine the socket collar diameter d4 will be obtained. ఇది మీరు ఫిగర్ లో చూస్తే ఇది d2 diameter, this one is a d4 diameter, so we can obtain this d4 diameter. Next one is failure of the socket end in the shearing. Therefore, since the socket end in the double shear, therefore the area of resisting is d of d4 minus d2 into 6. Therefore, the shearing strength is equals to 2 into d4 minus d2 c into t. Therefore, equating these two loads, we are getting P is equals to d4 minus d2 t into u. Therefore, with this wall, we will determine the thickness of the socket collar. Next one, the failure of rod end in the shear. Therefore, the rod end in the shear, because of the rod end is double shear, the area is equals to 2 into A into d2. Therefore, adding the strength 2 into A into d2 into tau. Therefore, equating this two with the load, P is equals to 2 into A into d2 into tau. With this equation, what will determine? We will determine the distance end of the rod A will be determined. Next, what is the ninth one? Failure of a rod, failure of a spigot collar in crushing. Here, this is a formula. So applying this one, P is equal to this one. Now, spigot collar in shearing. So pi d2 t1, applying the strength into tau, applying the load. That is the thing. So we'll calculate what? We can calculate the thickness t1. This one can be determined. Next, failure of a quarter in bending. So bending ela jarugutundi whenever the stresses, whenever the pressure is more, the load is acting is more, automatically you are getting bending in the quarter. Therefore, the bending momentum occurs at the center of the quarter and is given by m max is equal to p by 2. This is a formula. So this formulas you can see in the design data book, or you have to by heart it. So that's why I'm saying you 4th unit to 5th unit ఏం చెప్తున్నాము, and the 5th unit స్ట్రెస్ మనకి డిజైన్ షుడ్ బి సేఫ్, అంటే ఆ ఎక్సీడ్ అవ్వకూడదు, పర్మిసిబుల్ స్ట్రెస్ కంటే ఎక్సీడ్ అవ్వకుండా వీ హ్యావ్ టు సాల్వ్ ద ప్రాబ్లం. వెరాస్ ఇన్ దిస్ కేస్, by seeing the design data book only we can do, or we have to just by heart this failure theories, so that a formula is VSSC, we have to determine the diameters, different diameters, thickness, like that. Now with this, the modulus of the quarter Z is equal to T into B square by 6. Therefore, the bending stress induced in the quarter sigma B is equals to M max by Z. So that is equal to this one. The bending stresses should be less than that of the allowable bending stresses of the quarter. See here how the stresses are acting. So the stresses are see the forces in this direction, in this direction, in this direction. So this is a design analysis of this socket and spigot quarter. Next, what is the next one? The length of the quarter L should be determined. Length of the quarter L should be determined. Next one is the taper in the quarter should not exceed 1 in 24. In case of greater taper is required, then the locking device must be provided. The draw of quarter is generally taken as 2 to 3 mm, right? So these are the design conditions for this socket and spigot joint. Next, coming to the sleeve and quarter joint. Sleeve and quarter joint. Next one is sleeve and quarter joint. Second one is sleeve and quarter joint. Sometimes the sleeve and quarter joint shown in the figure 9. See this figure? This is a sleeve and quarter joint. So this figure kuda meer machine drawing subject lopala meer figure vesaru idi. Right or wrong? Right? So this figure kuda meer gurtu pettukondi. Is used to connect two round rods on the bars. In this type of joint, a sleeve or muff is used over the two rods, and then two quarters are inserted in the holes provided for them in the sleeve and rods. The taper of the quarter is usually 1 in 24. It may be noted that the two taper sides of quarter should face each other. The clearance is so adjusted that the quarters are driven in and come closer to each, thus making the job tight. Now, the various proportions of the sleeve and quarter in terms of diameter of the rod are as follows. The outer diameter of the sleeve. The outer diameter of the sleeve is equals to D1 is equals to 2.5D. The diameter of the enlarged end of the rod D2 is equals to 1.25D. See here. అన్ని ఇక్కడ కనిపిస్తుంది అనమాట. Or else if you see this figure also, right? The length of the sleeve L is equal to 8D. The thickness of the quarter 0.31D. The width of the quarter is 1.25D. The length of the quarter is 1.4D. So this is a sleeve and quarter joint. So if you see the design of sleeve and quarter joint, ila figure veyali. This is a D, there's a D1, this is a D2, this one is a A, this one is a 4.5D, this one is a 90 total. The length of the quarter is 80. This is the design specification of a sleeve and quarter joint. Now we will design the sleeve and quarter joint, right? We will design the sleeve and quarter joint. The dimensions of the sleeve and quarter joint may be obtained by considering the following modes of failure. So what is the first one to design? To design the rod's in tension. So ఇందాక మనం ముందు కేసులో చేసుకున్నాము దీనిలో కూడా అదే చేయాలి. So here the area is pi d square by 4. Then applying the tensile strength pi d square by 4 into tau t. Therefore applying the load P is equals to pi d square by 4 into tau t. So with this we will determine the diameter of the rod. Next one, the failure. Yes, we'll see the failure. We'll see the failure and rod in tension across the weakest section. So same ఇందాక మనం ఎట్లా చేసామో ముందు దాంట్లో స్పైకర్ దాంట్లో we have to derive in the same situation the tearing strength of a rod across the slot. Therefore the equating this one load P is equals to pi by 4 d2 square minus d2 into 2 whole to the power of sigma t. Therefore here the thickness is usually taken as d2 by 4. Here the d2 diameter can be determined. Next, third one is failure of rod or quarter in crushing type. So we know that the area is equal to d2 into t. The crushing strength is equals to dt into t into sigma c. Therefore the load P is equals to d2 into c into sigma c. Therefore the equating the induced crushing stress may be checked. Next, coming to the sleeve in tension across the slot. So the area is pi d square, that is pi into d1 square minus dt square minus d1 minus d2 into t. Therefore the tearing strength is equals to into sigma t. Therefore equating this to the loads P is equals to ఇది మొత్తం రాసేసేయండి as it is, right? With this equation all determined, we can determine the outside diameter sleeve can be determined. Next, what is the fifth one? Find the quarter. మీరు ఫెయిల్యూర్ అని రాకుండా ప్రాబ్లమ్స్ లో ఫైన్ అని రాయొచ్చు. ఫైండ్ ద క్వార్టర్ ఇన్ షియర్. ద ఏరియా అంతా 2bt, ద స్ట్రెంత్ షియర్ స్ట్రెంత్ వచ్చేసి 2bt into tau, equating with the load P is equal to 2bt into tau. With this we can determine the width of the quarter. Next, the failure of rod in the shear. The failure of rod in the shear. The area is 2 into A into D2. Therefore, the shear strength of the rod end is equals to 2 into A into D2 into T. Now, the equating with the load P is equals to 2 into A into D2 into tau. Therefore, here we can determine the distance A. What is the seventh one? The sleeve in the shear. Now, see here, the area is equals to 2 into D into C. Now with the shear strength 2 into d1 minus d2 into c into t tau. With the load P is equals to 2 into d1 minus d2 c into tau. So with this we can determine the distance c. Next one, the gib and quarter joint. Next design is a gib and quarter joint. So this is a gib. This one is a gib. This one is a quarter. This one is a other member, shaft member. So a gib and a quarter joint usually used in the strap end of the connecting rod as shown in the figure. Here the quarter alone is driven, friction between the ends of the distance prevent the thing are used which hold together ends of the strap. Thus, the tendency of the quarter is slacken back, owing to friction to considerable decrease. The jib also enables the parallel holes to be used. Okay. Now see the gib and quarter joint of rectangular rods. This is a figure, right? Next one, design of a gib and quarter joint for the connecting rod. Now we'll see the design calculations, right? The design calculations. So here, the thickness of the quarter is equals to width by 4, that is B1 by 4. Now the thickness of the gib is equal to thickness of the quarter. The height T2 and the length of the head L3 is equal to thickness of the quarter. Now T2, so this one is a top view, this one is a front view. So this is a design figure of this gib and quarter. So this is a strap, this is a quarter, this is a gib. So see here how the notations are arranged, how the nomenclature is arranged. Okay. So ఇవన్నీ కనుక్కోవాలి డిజైన్ చేసేటప్పుడు T2, T1, 3T, L3, L2, B1, B1, capital B, L1 like that. Now if you see the designing, what the first case? Tension. Failure design for the strap in tension. Therefore, the area is equal to 2 into B1 into T1. Applying the shear strength, 2 into B1 T1 into sigma T. Therefore, the load P is equals to 2 into B1 into T1 into sigma T. With this equation, we can determine what the T1 can be determined. Therefore, from this equation, we can determine the T3 also. The failure of gib and quarter in shearing action. So in shearing action, the area double shear is equals to double shear కాబట్టి రెండు తీసుకున్నాం అన్నమాట. For a double shear, everything if you see in the previous slides also, double shear కాబట్టి it is 2 into BT. Next, the resistance with the tau, the shearing stress is strength is equal to into tau, equating with the load P is equals to 2 into B into T into tau. With this equation, we can determine cap small b1 and b. The other dimensions may be as follows. T4 is equal to 1.5, 15 T2, 1.5 T1. L1 is equal to 2 T1, L2 is equal to 2.5 T1. Now design the gib and quarter jig for a square rods. So ఇందాక మనం ఇక్కడ వచ్చేసి ఏంటి, here it is in the connecting rod and the strap end connecting rod, but here it is square rod, right? So this is this one is a square rod. So for the square rod, again the same thing, the rods in tension, that is equal to x square into strength into tau 1, load equating P is equals to x2 sigma T. Now we can determine the x. Now the width of the strap B1 is equal to x. The thickness of the quarter T1 is equal to 1 by 4, that is equal to B1 by 4. The thickness of the gib is equal to thickness of the quarter, thereby H is equal to T2, length of the gib is equal to L4, that is equal to thickness of the quarter tau, thickness of the quarter T. Now the second thing is failure of the gib of the quarter in shearing. Shearing the double shear కాబట్టి 2 into BT, strength add చేస్తే into T, and load equate చేస్తే P is equals to D 2 into B into T into tau. Therefore, we can determine B1, we can determine B, we can determine width, we can determine the width of the quarter. And the failure of the strap end in tension location of the gib and the quarter. So this is a area of the failure. The strength into multiply the load is equals to 2 into x into T1 minus T into T into tau 1. So with this what we can do, we can calculate the T1. Next, the failure of strap in crushing. So crushing వచ్చేసి area 2 into T1 into T, adding the resistance strength 2 into T1 into T into sigma T. Therefore, adding the load P is equals to 2 into T1 into T into sigma C, crushing. Now the end in the shearing, that is equal to 2 into L1 into x, 2 into L1x into tau, 2 into L1x into x into tau. So with this we can determine the L1. Next in the shearing. So end in shearing, strap end anamata, that is 2 straps కాబట్టి 2 of 2 into L into L2 into T1 into tau into P is equal to 2 of 2 into L into T1 into tau. So with this we can determine L2 can be determined, and the length of the quarter is generally kept as 4 times the side of the rod, that is 2 into 2 is equal to 4. Next, design of quarter and connecting rod in a crosshead. So I think this maybe is not there in the syllabus, but Just make this student cross head lo unte see how the tapered piston rod is inserted like this, right? So here also maximum load is equal to pi d square by 4 into p. So here the again same, the rod in tension, then the rod in tension area into resistance into tensile strength into equating to p. So with this we can determine the d2. Next double shear kabatti 2bt 2bt into shearing strength, therefore equating p is equals to 2bt into tau. With this we can determine the b. So socket tension and the quarter. So this is area adding the tensile strength adding the load p. Therefore with this we can determine d3. Failure of socket in crushing, d3 minus d2 into t. Crushing strength into sigma c. Therefore equating p is equal to d3 minus d2 t into tau c. So with this we can determine the d. Now the next one is knuckle joint, right? The knuckle joint. So the knuckle joint is used to connect the two rods which are under tension and action of the tensile loads. However the joint is guided, the rods may support the compressive load. A knuckle joint may be readily disconnected for adjustments and repairs. It may be used to found in the link of the cycle chain. Tie rod. So according to system, this may be used in the link of the cycle chain. Tie rod joints for a roof truss. Okay. So the wall rods with the eccentric load, pumps and joints, tension link and the bridge structure and lever and the rod connections for the various types. In a knuckle joint, from the figure you can see the one end of the rods is made, the two eye of the end of the rods is formed in the fork. The knuckle pin passes through the bolt of the eye and forks and the taper pin or a split. The knuckle pin may be prevented from rotating in the fork by the means of small tops, big peg or snug. Now see here, in order to get the better quality of a joint, the sides of the fork and the eye are machined. The hole is accurate, so in the అవసరం లేదు. So if you get any question, uh, sketch and explain a knuckle joint అన్నప్పుడు simple గా మీరు ఈ knuckle joint figure వేసేసి you have to explain it, right? So this is the top view, this is the top view, this is the front view. So definitely I may give a question in this quarter joints for your mid 2. So there's a pin head, there's a double eye, there's a single eye, there's a split pin, there's a knuckle pin, there's a knuckle collar. See here the things what we have to identify: D, 0.6D, 0.8D, 0.25D, 0.11D, there's a T2, like this you have to determine. Next, coming to the dimensions of various parts of knuckle joint. The dimensions of various parts of knuckle joints are fixed by empirical relations given below. It may be noted that all the parts should be made up of the same material, that is a mild steel or wrought iron. So if D is the diameter of the rod, then the diameter of the pin is equals to D1 is equals to D. Outer diameter of the eye, dt is equals to 2d. Diameter of the knuckle, d3 is equals to 1.5d. Thickness of the single rod end, t is equals to 1.25, t1 is equal to 0.75, 2t is equal to 0.5. What are the methods of failure here? The methods of failure are there is no stress concentration, the load is uniformly distributed. Coming to the methods of failure, the first one is tension failure. అయితే ఏం జరుగుతుంది, 5/4 d square into tensile strength, that is sigma t. Therefore putting this one equating p is equals to 5/4 d square into t. In this we can determine the small d. Then the knuckle pier and shear. So 2 shear, double shear kabatti 5/4 d1 square into 2, that is added into shearing strength. Therefore equating with the p load, p is equals to 2 pi by 4 d1 square into tau. Next, third one is failure of single eye rod in tension. So this is the area, tensile strength, tearing tensile strength, and the load. So with this we can determine d2 and sigma t. Then the rod in shearing. So this is the area, the tensile strength, and the load. With this we can calculate the tau. The failure of a single eye rod in crushing. So d1t into crushing strength load equal to this one. So we can determine d1 and thickness and sigma tau c, sigma c. Fork rod in tension. So double fork kabatti, so we are having double eye, the fork end or double eye, we are having 2 of into area into strength. Therefore p is equals to 2 of area into sigma t. Next, failure of fork end in the shear. So this is equal to 2 of this one into tau into P is equals to this one. With this we can determine T1. Next, failure of fork end in the crushing. So area into crushing strength equating with the P, we can determine T1 into T1. So this is a 3D figure of knuckle joint, right? So I think I've already drawn this figure also, knuckle joint. So where these are used in the elevator chains, valve rods, etc. What are the design procedure? The following procedure may be developed. Saying on call here, first of all, you have to find the diameter of the rod by considering the failure of the rod in tension. So failure of the rod in consider this cone. First, we have to find the diameter of the rod, that is equal to P is equal to pi by 5 pi by 4 d square into tau t. Next, determine the diameter of the rod. Then determine the diameter of the pin may be determined by considering the shear, that is equal to 2 of this one. Next, other dimensions of the joint are fixed by empirical relations as discussed. So this everything will be in the design data book. Only thing is you have to practice, you have to open your book, see thoroughly where the units are there, where to see the table. Next, coming to the problem, design a quarter joint to connecting piston rod of a cross head of a double acting steam engine. Diameter is 300 mm, pressure is 1 mm, the stresses are given. So first write the given data, d, p, tau t, tau 1, tau and sigma c. So we know that what to know the load, we know that the maximum load p is equals to, we have to find in tension, that is pi by 4 d square into p. So with this we are finding p is equals to this one. Now considering the design considerations, first find the diameter of the piston. So first failure diameter of the piston diameter of the piston rod at the quarter, d is equal to diameter of the piston, t is equal to thickness. Now applying here pi by 4 d2 minus d2 square minus d2 into t into tau t. So applying this one, we are getting the values, that is 55. So with this 55, apply here t is equals to this one, we are getting t value. Next is the width of the quarter. B is equal to width of the quarter. Considering the failure, P, మనకి P వచ్చింది కాబట్టి P is equals to 2 into B into tau. So apply చేస్తే మనకి B value is 54 or 55. Now the diameter of the socket, D3 is equal to diameter of the socket. Applying the same, we know that the load P is equals to, applying the socket formula. So we are getting the D3. D3 value is 72. Now keep on doing this one. So we are getting the length, we are getting the D value, we are getting the D1 value. Next, problem 2. Design a sleeve and quarter joint. Sleeve and quarter joint with the load 60 kilo and as per the material given. Sigma T this one, tau is equal to this one. So the P is equal to 60 kilonewton, tau T is equal to 60, tau is equal to 70, sigma C is equal to 125. Now first find the diameter of the rod, D. So therefore pressure P is equals to pi by 4 d square into sigma T. So with this we can find diameter is equals to 36. Next, diameter of the enlarged end of the rod D2 is equals to so and so. Thickness is this one. So with this we can find the diameter dt is equals to 44. Next, the thickness of the quarter dt is equals to 11 mm. Now let us find so and so, we are getting sigma c. Then outer diameter of the sleeve d1 is equals to so and so. And upon keep on solving this one, the same in the ముందు చేసినట్టు చేస్తే we are getting the values. Next, the width of the quarter b is equals to width of the quarter, applying with the double shear of load p. P is equals to 2 into B into T into tau. So applying this one, we are getting B. Distance of rod from beginning out to the quarter hole. So A is equal to this one. So applying this one, we are getting this one. The distance of rod end from the end of the quarter hole. C is equal to this one. And then the value is this one. Next, quarter joint problem. Design a draw on quarter joint to support a varying load of 30 kilonewton, compression 30, so on so values. So the P is 30, tau T, tau and sigma C. Determine the diameter of the rods. D is equal to diameter of the rod. So on so we are getting D is equal to 27 to 28. Now the thickness of the quarter, dt is equal to T is equal to values తీసుకోండి. Apply చేయండి. We are getting T value is equals to 8.5. Next, checking with that, we are getting crushing stress. So we are getting the D2 values and also T value. Then outside diameter of the socket, D1 is equal to outside diameter of the socket. ఈ ఫార్ములా అప్లై చేస్తే ముందు ఎలా చేశారో సో ఆర్ గెటింగ్ ద D1 value is equal to 50. Now the width of the quarter B, same applying with the double shear P కాబట్టి P is equals to 2B into T into tau. We are getting 43 and 45 వేసుకోవచ్చు. Now the diameter of the socket collar D4. D4 కనుక్కోవడానికి this is the formula. Applying this one, you are getting D4. Now the thickness of sixth one. Sixth one is we have to determine, or simply we can say the thickness of the socket collar, C kanukkowali. So applying the formula, you are getting C. Distance from the end of the slot, A. So like this, diameter of the spigot collar, D3 kanukkowali. So applying this formula, we are getting D3 value. Next, thickness of the spigot collar, T1 kanukkowali. So the failure of load P is equals to pi D2 into T1 into tau. So finally you are getting thickness. The length of the quarter is equal to 4T. Vachina D to 4 into D pettandi, you are getting 112. The dimensions of E is taken as 1.2D. So E is equal to 1.2 into 28, that is equal to 434. So like this we have to design the things. Next, the last topic in this unit 4 is design of shaft. What's the meaning of shaft? A shaft is a rotating member, usually of circular cross section, which is a solid or which is a hollow, which transmit power from one place to the other place by rotating motion. Machine elements such as gears, pulleys, sheaves, flywheels, clutches, and sprockets are mounted on the shaft and are used to transmit power from the driving device to the through the machine. Press fit, keys, dowels, pins, and splines are used to attach these machine elements on the shaft. The shaft rotates on a rolling contact bearings or bush bearings. So shaft ఎలా rotate అవుతుంది? These are rotated by rolling contact bearings or the bush bearings. The various types of rings are retaining rings, thrust bearings, grooves, and steps. The couplings are used to transfer the power from one driven shaft to the driven shaft. See here, the connecting rod is loaded primarily in torsion. So ఇది మనం మోటార్ అనుకుంటే ఇది మోటార్ షాఫ్ట్, ఇది వచ్చేసి కప్లింగ్ అటాచ్ చేస్తాం, ఇది వచ్చేసి నార్మల్ షాఫ్ట్. ఈ షాఫ్ట్ ద్వారా మోటార్ షాఫ్ట్ నుంచి నార్మల్ షాఫ్ట్ నుంచి డ్రివెన్ మెషిన్ కి ఇది రొటేట్ అవ్వాలి. సో దీని వాట్ ది కాన్సెప్ట్, ఇక్కడ మనం బేరింగ్స్ పెడతాం. ద బ్లూ కలర్ పోర్షన్ ఇస్ ద బేరింగ్స్. సో ద షాఫ్ట్ ఈస్ ఫిక్స్డ్, ద షాఫ్ట్ ఈస్ మౌంటెడ్ with the motor bearing by the means of coupling, and ఇది మూవ్ అవుతుంది. The driving machine will be moved by the means of shaft by using this couplings. This is a general setup of a connecting shaft. Then coming to the types of shaft, we are having two types of shaft. First one shaft is transmission shaft and the machine shaft. What's the transmission shaft? This shaft transmit power between the source and the machines absorbing power. The counter shafts, line shafts, overhead shafts, all the factory shafts are transmitting the shafts. Since these shafts carry machine parts such as pulleys, gears, etc., therefore they are subjected to bending in addition to twisting. Machine shafts, these shafts form integral part of the machine itself. అంటే ఫర్ ఎగ్జాంపుల్ ఒక మోటార్ ఉందనుకోండి, ఆ మోటార్కి డెఫినెట్గా మనకి చిన్న షాఫ్ట్ ఉండాలి. ఫ్యాన్ ఉందనుకోండి, ఫ్యాన్ రొటేట్ అవ్వాలన్నా ఒక షాఫ్ట్ ఉండాలి. దీస్ ఆర్ ద shafts which are assembled, which are the integral part of the machine itself. The crank shaft is an example of a machine shaft. అదే ట్రాన్స్మిషన్ అనుకోండి, ఇందాక నేను చెప్పిన ఎగ్జాంపుల్లో ఈ మోటార్ ద్వారా ఈ డ్రివెన్ మెషిన్ తిరగాలి కాబట్టి ద షాఫ్ట్ అనేది మనం ఇక్కడ ఇన్సర్ట్ చేస్తాం కాబట్టి ఇట్ ఈస్ ట్రాన్స్మిటింగ్ ద పవర్ ఫ్రమ్ మోటార్ టు ద డ్రైవింగ్ మెంబర్. సో లైక్ దిస్ వీఆర్ హ్యావింగ్ transmission shafts and machine shafts. Next, what are the stresses here? The following stresses are the shear stresses due to the transmission of torque. Next one is bending stresses due to the tensile or compressive stresses. Third one is stresses due to the combined torsional bending loads. Then coming to the design of shafts, the design of shafts may be designed on the following basis of strength of the shaft and the rigidity and stiffness of the shaft. In coming to the designing of the shafts on the basis of strength, the following cases may be determined. Shaft subjected to the twisting movement or torque only. Shaft subjected to the bending movement only. Shaft subjected to the combined twisting and bending moment. Shaft subjected to the axial load in addition to the combined torsional bending moment. Now we'll see each one by one. Shaft subjected to solid shaft. Shaft subjected to the twisting moment ki cheste solid shaft is equal to T by J, that is equal to tau by R. So the notation here ni meer oksaరి chuskondi. Next, For the solid shaft, the moment of inertia J is equals to pi by pi 32 d to the power of 4. So ఈ shafts గురించి కూడా if you see your design data book, you can see all the content what I am teaching now, right? Now we get T is equals to pi d cube by 16 into tau. So with this equation, we determine the diameter D. Next, coming to the hollow shaft. Hollow shaft momentum of inertia is equal to this formula, where D1 and Di and D are outside diameter and inside diameter. Therefore, after substituting this one, we are getting T by so and so. So finally, we are getting T value. So with this K is equals to ratio of the inside diameter and the outside diameter, that is Di by D naught. Next, we can write like this: pi by 4, 1 minus k to the power of 4. Next, coming to the, in case of belt repeat, the twisting moment is equals to, this is the formula. Next, shaft subjected to bending moment only, solid shaft. ఇందాక మనం తీసుకుంది hollow shaft, ఇక్కడ వచ్చేసి solid shaft. For this, the bending equation is m by I minus sigma b y, where m is equal to bending moment, I is equal to moment of inertia, sigma b is equal to bending stress, y is equal to distance. Next, we know that the solid shaft I is equals to I minus pi by 64 into d to the power of 4. So like this, we are getting the, we can determine the diameter of the solid shaft. Next, coming to hollow shaft. So applying the formulas, keep on doing the formulas, we are getting inside diameter and outside diameter. Now the shaft subjected to total combined twisting and bending moment. So దీనికి we are having Guest theory and Rankine theory. Therefore, let tau is a tau stress, shear stress, sigma p is a bending stress. Therefore, the solid shaft tau max is equal to half root of sigma b square minus 44 tau square. Therefore, substituting the values, we are getting root of m square plus t square, right? Next, so keep on solving, you are getting these equations. Okay, then for the hollow shaft, in case of hollow shaft, so these are the equations. So the problems for the shaft. The shaft is supported by two bearings 1 meter apart, 600 diameter. So ఇవన్నీ ఒకటికి రెండు సార్లు చదవండి. First write given the data neatly and write the what to determine and రాసేసి మీకు నచ్చిన మినిమం ఫార్ములాస్ స్టార్ట్ చేసి వదిలేసేయండి. So this is a given data. So given data neatగా రాయండి. The torque is equals to T1 minus T2 into RD. Applying this one, we are getting the values. So the values we are getting by using this formulas. Okay, so WC is equal to WC into cos 20, WCH is equal to WC into sin 20. So ఈ బెండింగ్ ఆల్రెడీ మీ క్లాస్లో ఈ బెండింగ్ మూమెంట్స్ డయాగ్రామ్స్ మనం చెప్పుకున్నాం. వెర్టికల్ లోడ్ డయాగ్రామ్, హారిజాంటల్ లోడ్ డయాగ్రామ్, వెర్టికల్ బెండింగ్ మూమెంట్, హారిజాంటల్ బెండింగ్ మూమెంట్, రిజల్టెంట్ బెండింగ్ మూమెంట్. జస్ట్ మీరు ఒకసారి చూసి ప్రాక్టీస్ చేసుకోండి. సో ఇవన్నీ మిడ్ ఎగ్జామ్స్కి రావు, బట్ మీరు ఒకసారి గుర్తు చేసుకోండి వాట్ ఎవర్ ద టాపిక్స్ వాట్ వి ఆర్ టాట్, రైట్? So these are the values what we have got. These are the derivations what we are doing for the maximum bending moment, right? Diameter of the shaft, that is equal to formula. This formula, this one is the thing. So by equating with the twisting moment, so we are getting D3. Therefore, finally D is equal to 55. Next, for the second problem. So write the given data. Same ఇందాక మనం చేసినట్టు చేసుకుందాం. T is equal to this one. So the number of teeth, RC is equal to so and so, RD is equal to radius of piston, FCTC, FTD. Same, the vertical load diagram, horizontal load diagram, vertical bending moment diagram, horizontal bending moment diagram, resultant bending moment diagram. Same, మళ్ళీ అదే చేయండి అదే ప్రాసెస్లో at C, at B. Therefore, with RAH and RAB, so while you are getting this value and bending moment at A and B, so we are getting at MC at MD. Therefore, the maximum bending moment with this torque twisting moment, and finally you are getting D is equals to round figure 50. Next, shaft subjected to axial load in addition to the combined torsional bending moment. So దీనికి వచ్చేసి bending moment M by A is equal to sigma B by Y. So stress axial load. So finally we are getting these values, right? Column factor. column factor C for hinged ends, for fixed ends, and for the ends that are partly resisting. So for this, these are the values. Next, problem 3. The hollow shaft is subjected to so and so maximum torque. So direct formula apply cheyandi, given data రాయండి, write the given data, T is equal to so and so, apply directly, we are getting the value, right? Next, problem 4. A hollow shaft so and so, determine this one. So first write the given data, maximum stress formula వేయండి, T is equal to so and so, apply this bending moment, so we are getting this one. Now the K factor is equals to so and so formula, so finally we are getting K. The slender ratio L by K is equals to so and so, we are getting the column factor this one, the K values, the T value, and finally we are getting the tau value. The angular twist between the bearings theta is equals to angular twist, therefore J is equals to this formula. From this torsional equation, T by J is equals to G into theta by L. So with that, we are getting theta is equals to 0.275. So next, design of shafts based upon the rigidity, torsional rigidity. For this torsional rigidity, the torsional deflection may be obtained by using the relation T by J is equals to G theta by L, that is equal to theta is equals to so on. So these are the notations, right? Next, lateral rigidity. For this lateral rigidity, we are having d square by y, that is equals to m by I. Then what are the BAS codes of the shafts? The standard size of the transmission of shafts are 225 mm to 60 mm for 5 mm steps, 60 mm to 110 steps with 10 mm steps, 110 mm to 140 mm with 15, 140 to 500 with 20. The standard lengths of the shafts are 5 meters, 6 meters, and 7 meters. So maximum, because of this transportation, because of this accommodation, because of this handling, the shaft should not exceed beyond the 7 meters. Next. Next, fifth problem, that spindle transmits so and so RPM, determine that this is one. So write the given data. So apply the, first find the diameter of the T by using the diameter of the spindle. So this is the T formula, we are getting the diameter. Then we, with this formula, we are determining the D value. So the stresses induced in the spindle, this is equal to this one. So with this, we have successfully completed the design of so with this we have completed the design of shafts, design of cotter joints, design of keys, and the concepts of circlips, gaskets, and the seals. So if you have any doubt, we can talk to me. So these are the problems. So in this syllabus only 4, 5, 6 only I'll give, prepare the question paper for the mid-2. So ఈ చెప్తున్న స్లైడ్స్ లో కూడా మీకు ఒక ప్రాబ్లం వచ్చే ఛాన్స్ ఉంది, రైట్? So with this I'll stop the class. We'll continue in the other lecture, right? సో ప్రాక్టీస్ బాగా చేయండి, ప్రాబ్లమ్స్ ఎక్కువగా, అండ్ ఆల్సో క్లాస్లో మీకు ఏం చెప్పానో ఒకసారి ఓపెన్ చేయండి. ఈ ఆన్లైన్ క్లాసెస్లో కాకుండా మీకు మీ రన్నింగ్ నోట్స్ చూస్తేనే మీకు ఒక ధైర్యం వస్తుంది, రైట్? మీ రన్నింగ్ నోట్స్ ఓపెన్ చేస్తేనే మీకు ఒక ధైర్యం వస్తుంది. సో దట్ ఓపెన్ యువర్ నోట్స్, కీప్ యువర్ నోట్స్ అండ్ కీప్ యువర్ రఫ్ బుక్, practice the problems, open your design data book, see the concepts of the design data book, then only it will come to from understanding, right? So with this I'm stopping the class, we'll discuss in the next class.